Okay, this is the dot product. So the dot product of A, which is the vector A1, A2, and B, which is B1, B2, is defined as A dot B, not A times B, but A dot B. So we're calling that the dot product, where you take A1 and B1 and you multiply them to each other, and you add them to A2 and B2. Now, let's go ahead and just look at two examples. I actually had them in the next slide, but I'm going to actually do them right here so you guys have this right up top for you. So our first example, we'll call it A. A says that vector U is 3, 6, and vector V, I'm trying to make it a little more bold, is -4, 2. We want to know the dot product of U dot V. How do we do it? Well, 3 times -4 plus 6 times 2. This is similar to the linear algebra multiplication that you guys did. Totally different concepts, but once again, it's another way to do things. -12 plus 12, oh, this equals 0. That brings in the concept of orthogonal. Orthogonal vectors are vectors that when you have the dot product, it equals 0. So two vectors are orthogonal if and only if A dot B equals 0. So in this case, we would say that U and V are orthogonal. If it equals anything but 0, they are not orthogonal, right? Let's go ahead and look at another example. Let's zoom this out. So example B is if U is 2, 5, and V is 8, 4. So U dot V is a 2 times 8 plus 5 times 4. The nice thing to know is if you have everything positive, they're not going to be orthogonal. They won't cancel each other out. So this is 16 and 20. So 36, they're not orthogonal. So the dot product is just UV 36. And that's it for this one. Go ahead, make sure you have dot product, orthogonal, and the two examples down before you move on.